Hey Algebra 2, this lesson is titled Compositions of Functions. Well, what does that mean? Well, I will tell you. You're going to get two functions. For example, you have f of x is equal to x plus 5. And your other one I'm going to give you is g of x equals x squared minus 10. Now, there's certain formats that you're going to have to get used to. And it looks like this. If I were to give you something like this and say I want you to solve, the way we read this is we say g of f of 2. What that means is first we're going to plug 2 into the f function. On these you start on the inside and work your way out. So right now forget about the g. We see f of 2. That means plug in 2 for x. So that gives us 2 plus 5. Okay? So again, we plugged it in, 2 plus 5, therefore we have g of 7. So now instead of f of 2, we say g of 7, because we plugged the 2 into the f function for x, 2 plus 5 is 7. So now we find g of 7, so we go to the g function and plug 7 in for x. So that gives us 7 squared minus 10, which is 49 minus 10, so our final answer is 39. That's how we do this problem. Again, start on the inside. You're going to plug 2 into x on the f function. So 2 plus 5 is 7. And that now it says g of 7, so you plug 7 into x on the g function. 7 squared is 49, minus 10 is 39. Let's do another one of those. If I were to say f of g of negative 3, okay? So now, forget about the f, we're going to plug into the g function. So if I were to plug negative 3 squared minus 10, okay, so that gives me f of negative 3 squared is 9 minus 10, so that's f of negative 1. So now, we're going to plug negative 1 into the f function. So it gives me negative 1 plus 5, which is 4. So that would be your answer for this problem. Again, plug the negative 3 into the x on the g function. So it gives us 9 minus 10, which is negative 1. And we're going to take that value and plug it into the f function in for x. So negative 1 plus 5 is 4. Okay? So that's how we read that. G of f of 2, f of g of negative 3. You might see something like this. F of 1. The way we would solve that, again, plug 1 into the f function, so you get 1 plus 5, which is 6, so f of 6. Now you're going to plug into the f function again for x, so you get 6 plus 5, which is 11, okay? So f of 1, plug 1 in for x, you get 6. Now it says plug it again into f function, you get 11. So that's how we do those problems, but now let's do a little bit tougher now. Or I'm just going to say, what's f of g of x? So we're going to use our same equations up here. X plus 5, f of x equals x plus 5, g of x equals x squared minus 10. It says take whatever g of x is, in this case we know it's x squared minus 10, and plug it into x on the f function. So you have x squared minus 10, and you're plugging it into this x. So that leaves just a plus 5 on the outside. So now, combine like terms, your final answer would be x squared minus 5. That's what f of g of x would be. Now, you don't get the same thing if you were to flip that around. G of f of x. Now, I'm going to take the f of x function, which is x plus 5, and plug it in to x on the g function. So now, it looks like this. X plus 5 squared minus 10. Because you're taking your f of x and plug it in to x on the g of x. So now we actually have to FOIL this out. So we use our special products here. This gives us x squared plus 10x plus 25. I use our special products formula or identity from our previous lesson. Okay, math builds on itself. We're going to use the stuff from before to help us now. And so I turn this into x squared plus 10x plus 25, and then we have the minus 10. So finally, we just combine like terms. So our final answer would be x squared plus 10x plus 15, because 25 minus 10. So that's how you solve compositions of functions. Again, you have two functions. To find g of f of 2, plug 2 in, see what you get, then plug it into the g function. Same thing here. Plug negative 3 into the g function, see what you get, plug that into that function, and solve. And again, when you have f of g of x, you take your whole g of x right here, and you're going to plug it into x on the other function, and vice versa. Okay? And if you need to simplify like we had to do here, and you need to multiply that out, then by all means do that. So that's how you solve compositions of functions. So good luck with that.